lot about the streets. This is where people, where the public, um, not just moves around in the city, but also gather, do business, socialize. So good streets should allow not just for movement of people and vehicles, but also social interaction and economic activities. So over here with a map of New York street network, notice there is a hierarchy of different streets and roads. So we have the highways, the major roads, and the minor roads. One of the challenges in Cebu City and maybe wherever you're from is that there doesn't seem to be, at least in the Philippines, um, very clear hierarchies of roads. We have roads of different widths, but sometimes the uses of those roads don't coincide with their widths. Like we have very big, like 30-meter roads wide, or like 15-meter wide roads are being used as minor thoroughfares when it should be major, stuff like that. So that could be an interesting topic of study and discussion as well. Traffic signals. You've seen these. Some of them are not working. Some of them are like just decorations. Uh, there's a nice section here on split facing. How do you manage like vehicles and people in a crossing or an intersection? Like it shows here that for cars coming in on the, what do you call this, on the right hand side going to the left hand side, you need to allow like cars will need to turn right here, so you need to stop people from crossing that at least until there are no more cars who want to turn right in this like a pedestrian area. And basically, split facing is one way of managing that, making sure the pedestrians can use the intersection at the same time the cars are using it. So that could be like one example that you might look into, or like some thesis examples. Let's see, traffic cameras. There's a few, I think a lot more in Mandaue. And if you guys know that your city is using traffic cameras, please let me know. And the kind of effects we're trying, or like traffic engineers are trying to achieve, this is another kind of system, is to have vehicles move more easily through the city. So over here is a diagram of speeds across New York City. This is before their intervention or their program. You see a lot of red and orange, meaning slow speeds. And then after the program, more yellows and blues, meaning faster speeds or easier travel. So that's the goal of traffic engineers. On the other hand, what if you want to reduce the speed of vehicles and going through the streets? So you need to use traffic calming measures. So I'm just talking about this to like give you guys of the different kinds of activities and systems that can be applied in an urban setting. So you use traffic programs to increase vehicle speeds, and then you use traffic calming measures to reduce those speeds to allow like a more safe environment for pedestrians in very specific areas of the city. Like so, you need a hierarchy. You need an area where cars can go fast, and there are no pedestrians, and an area where cars go slow because there are pedestrians there. So these are the different sort of treatments you can use. I'll be giving a copy of this as well. So this is just my own scan. I couldn't find an online version of this book. And it's a really kind of simple book, but I really like the illustrations. Very useful for discussions. So over here, this is an example of a traffic calm street. They inserted islands so it's easier and safer for pedestrians to walk. Maybe something like this is a little bit too big for Cebu City at the moment, but this could be applicable in your city, or like if some of you are from Manila. By the way, where is everybody living? Don't tell me your address, just like your city. You can like leave it in the chat box over here. Okay. I see. I imagine you guys are like eating and or whatever. Anyway, this is being recorded. So street surfaces, what's going on underneath our streets? Ideally, we should have our drainage systems and supply systems built into our public spaces underneath the streets. So this is a diagram showing the sewer system over here and the different sort of soil types. I'm not too familiar with this, so you can just peruse that at your own time. Then how potholes are formed, that might be interesting. And very more interesting is like how smooth are New York streets. They actually studied this, like which areas of the city have very smooth sidewalks and roads. And you notice the northern part of New York has better, what do you call this, street smoothness. And street smoothness could also be kind of connected to like the quality of that area, like Upper Manhattan, um, and this like area here above Brooklyn could be the more high end, because like better infrastructure usually means richer people are staying there because they can afford those uh road improvement program, something like that. And you can see here where the smoothness are low. Oh, sorry, light is actually the high end, and dark purple is the low end, like 50 to 59%. Sorry, I got confused there. So the better infrastructure is here in the lighter colors, and the not so good infrastructure is in the darker colors. Notice how like there's not so much intermingling. Most of the kanang, what they call this, the smoothness or the quality of the infrastructure. Like if you're in an area with good infrastructure, chances are like in a certain like few kilometer radius, all of that area needs will have the same quality of infrastructure. And then after a certain point, it becomes bad. That could symbolize like a different sort of barangay or kanang local government unit that is like doing a poor job of their kanang street smoothness or street infrastructure. So this kind of data is like very interesting to me. That's why I wanted to share it with you guys. Street signs, that's like very straightforward. And I think some of you, the landscape architects, will be interested in like maybe creating a map for street trees. And there's a lot in Cebu City because we're basically 70%, what do you call this? 70% unbuildable area. So if I zoom out Cebu City over here, so let me just put the outline of Cebu City on the screen. So that's the border, that's the kanang outline or the border of Cebu City. And I think it's very easily, it can be easily said that I think about 70% is natural preserve or like natural reserve lands, because these are our kanang um, in Cebu City, our rainwater reservoirs, our kanang natural vegetation, and of course, this is how um, Cebu City manages like our um, tropical typhoons. Like if we have more green surface area, permeable surface area, rainwater during typhoon season would be more readily absorbed. The problem is we're developing more and more into our like mountainside, and that has been influencing flooding in the lower parts of Cebu City because there's more development in the mountains. There's less rainwater absorption, and then what happens is we got flooding in the lower parts of the city. So I think local government is trying to manage that. I don't know what kinds of plans are in place, but that's really one problem that is specific for Cebu City. So at the end of this lecture, I would like you to do like a profile or like data gathering for your specific city. I'll discuss more about that after I go through more parts of a city in our cunning reference book. So street trees, that's one element of a city. Pedestrians, we talked about this in length. Subway could be an option for Cebu City, but I think before a subway, we'll have like an above ground railway or like a light rail system. Subways and trains are very efficient at moving a lot of people great distances in a short amount of time. And eventually, all developed cities will have trains. And then I think Cebu City will undoubtedly have some kind of train system, at least um, not now, definitely not now, or not in the near future, but probably like 20, 50 years down the line. We'll definitely need more trains because of the amount of population growth we're experiencing, even in the pandemic. I think we can quickly go to that Cebu City population over here. It's not as a great increase as Davao and Manila, but it is increasing. So we'll just need to prepare for that. Those are the kinds of things that urban planners, urban designers need to think about. We're not just thinking about 5, 10 years into the future, but like 25 and 50 years, really long term. These are the goals of urban designers and urban planners. Markets, commercial areas should be identified, and if you know where they are, that's basically the places of work. So people will be living in the residential areas, and then they'll be working, of course, in the commercial areas. The key factor here is how far away are they living from their work office areas and commercial areas. And if that distance becomes too long, then you will have traffic congestion. And because you have traffic congestion, you have so much CO2 going into the air, and that's another system altogether, like how much pollution, not pollution, CO2 specifically, is the city generating. And speaking of like generating, the other element of the city is power consumption. So this is a very interesting map over here. You have New York City, and then that's how big it is, and everything here is to scale. Compared to Rhode Island, which is probably twice the size of New York City, it has like, despite being a smaller city, New York almost has like double, if not triple, the sales per megawatt hours and the number of consumers as well. In Rhode Island, there's 413,000 people. In New York City, there's 2 million people using over 11 million megawatt hours of electricity compared to Rhode Island with at only 2 million. And then some other examples here, you have Michigan. I think this is the whole state of Michigan. I'm not sure about the um, local government units in America. Connecticut. So it looks like this. So generally, you can't judge the size of a city as like an indicator of how much people are living there and how much electricity or power they're consuming. So that could be a different thing. Very interesting. Some diagrams here showing wattage of like different appliances. You got lamps, hair dryers, etc., etc. So let me just wrap this up a little bit. So this is why currently we're going to talk about sustainability next week. Why we need to have alternative energy sources, because electricity is currently mostly coal powered. So we need alternative sources of electricity. That's why we're talking about wind power, solar, hydroelectric, geothermal, and I think the other one over here is biofuel or biomass. So those are why cities and as a result, urban planners and urban designers have to think about alternative energy sources. So this is just a diagram of how power gets distributed in the city. Blah, blah. You can look at that later. And one more element of the city is water distribution. So where do we get our drinking water from? Who's the company in charge of that? Do we have the infrastructure for that? Is everyone in the city getting their daily amount of like, or the required amount of daily water? So ideally, water supply uh, happens like in the public spaces, like underneath the streets, and then they get pumped into the private spaces, the different buildings, by their water service provider. So if the infrastructure isn't there, then it's very difficult to provide clean water to those different areas of a city. And that's been going on, I think, in Cebu City for a long time, where our drinking water is not from the tap, but we have to buy our kanang 1 gallon, not 1 gallon, but the big plastic barrels of drinking water, because we don't have the infrastructure in place. So that's one big challenge for Cebu City. That's water, the different consumptions of like water, like a washing machine uses 56 gallons. So this is like a general overview of like how much water are we using in the city. And then when you have when you have drinking water, you also have wastewater. So sewage system must be in place. And then when you have a sewage system, you also need to have a sewage treatment plant. Some other items would include, like for architecture and individual buildings, catch basins, sort of to mitigate flooding in the city. So these could be different elements. So we're thinking about big scale all the way down to individual buildings. And then I think finally, this is the last element, garbage. Where does the trash go? So trash can be divided into physical trash, and the physical trash can be divided further into recyclable and non-recyclable. Are we like, is your city doing a good job at segregating trash, managing trash? Street cleaning is another sort of luxury in developed countries that developing countries don't have. Like in Cebu, we just have the street cleaners with the broom. So the more developed your city is, your street cleaning systems will also become more developed, because really a clean city like provides like a very attractive public image. So you have here a scale, New York scale here. You have 1.0, a clean street with no litter; 1.2, clear with just a few traces of litter; all the way down to 3, which is filthy litter, very concentrated, both in a straight line along and running over the curb. So these are the kinds of things, or metrics or measurements, that need to be in place to sort of have a plan for the city, have a guide to maintain like not just street cleanliness, but also like any other kinds of goals you want to achieve in the city. So that I think that's the last part of that.